Hello everyone. In this video we will be learning about Kirchhoff's voltage law, which is abbreviated as KVL. Now this law states that the algebraic sum of all voltage drops or rise around the circuit must be 0. So we know voltage drops across all these components will give us 0. We know that voltages can be positive or negative. So it is up to us to determine which ones are positive and which ones are negative. Now let us consider a resistor where this is 10 volts and this is 5 volts. We know that current always flows from higher potential to a lower potential inside a resistor. So the energy from the charges moving through the resistor will be consumed by this resistor. Now since this resistor decreases the energy of the charges, we will assign a negative voltage to the voltage across this resistor. So we'll call it minus V. Now let us consider a battery. In a battery, the current flows in both directions. So it can go from higher to lower and from lower to higher potential. When the current goes from lower to higher potential, the energy of the charges will increase, which means the battery will give energy to the charges moving through the circuit. So this will give us a positive voltage. When the current goes from higher potential to the lower potential, the energy of the charges will decrease. So this battery will take away the energy from the charges. So we will get a negative voltage. Now let us solve a problem. Now we know that the current loop always starts from the positive terminal of the battery, where it goes from negative terminal to the positive terminal. So we will have plus VB, which is the battery voltage. Then we have a resistor which is 6 ohms, and the voltage across this will be negative since it is a resistor. So we will have minus V1, and voltage across this resistor will be minus V2, and voltage across this resistor will be minus V3. And according to this law, the sum should be 0. Now let us verify this theorem. Now we have only one current flowing through this circuit since it is a series combination. So let us call it I. So we know that V is equal to I times R. So V1 will be I times R, which will be 6 ohms. V2 will be I times 5 ohms, and V3 will be I times 12 ohms. Now this equation takes the form 18V minus 6I minus 5I minus 12I is equal to 0. So when you take this sum to the other side, we will get 18V is equal to 23I. So the current flowing through this circuit will be 18 by 23 ampere, which is 0.78 ampere. Now let us say that electric potential at this point is 0 volts, and now we have to find the potentials at A, B and C points. Now notice that the potential difference across the battery is 18 volts, and since A is at the positive side of this battery, the potential at A will be 18 volts. VA will be 18 volts. Now we need to find the potential difference across points B and A. So VB minus VA is equal to IR. We have already calculated R to be 0.78 ampere. So this will be negative since it is a resistor. VB is equal to VA minus IR. So VB is equal to VA is 18 volts. So 18 minus 0.78 times 6. So we will get 13.32 volts. Here the potential will be 13.32 volts. Now we have to find the potential difference across this resistor and the potential difference between the points C and B. So VC minus VB will give us 0.78 times 5 ohms. So VC is equal to 13.32 minus 0.78 into 5. Now this will give us 9.42 volts. So at point C the potential will be 9.42 volts. Now we have potentials at point A, B and C. So this is how you solve a problem using Kirchhoff's voltage law. I hope this video was helpful and I'll see you in the next one.